very short. Ankit, can you please mute your mic? Ankit, can you please mute your mic? Too much of noise. Ankit Kumar. Thank you. Great. So today's class is very short. We will just finish two different ways in which niche partitioning happens, and then what I'll do is I'll dissolve the class as soon as that is done, and then I will hang back, and so basically whatever things or whoever was planning to meet me during the office hours, we can finish that right over here. Okay, and then maybe we can take a break with the office hours. Okay, it all depends on when we finish, but I hope that I'll be able to finish pretty soon, because there is hardly just two topics for today. So okay, okay. So this is where we left yesterday, and so we talked about spatial separation, we talked about temporal separation. Now we are going into morphological separation, and this is a phenomena called character displacement. Now let me first give you the example, and then we'll talk about what the phenomena per se is. So you remember those Darwin's finches that we talked about in the last year basically. So these are very closely related birds which are found on the Galapagos Islands. Now if you know about the Galapagos Islands, you have a chain of islands, so different sizes, small, large, etc., but which have a reasonably similar kind of vegetation and climatic conditions and so on. So in some sense, the populations on these almost act like replicate populations. So you have three different species of this Darwin's finches over there: Geospiza fulginosa, fortis, and magninostris. Now, as you can see that these birds have very different shape and size of their beaks. Now, in the context of these birds, their beaks are very important, in the sense that these beaks determine what is it that they can eat. So the kind of resource to which they have access is entirely dependent on the size and what is known as the beak width, this thing. Okay, this determines what is the size of the fruit that they can crack, and also the musculature over here that determines how hard a fruit or how hard a seed they can crack. Now if you look at some islands, Pinta and Marciana, then if you look at the frequency distribution of the beak size, then you see where they are occurring together, these three frequency distributions are absolutely non-overlapping, okay, for these three species. However, if you look at another island where only two of the species are found, then you see that this distribution and this distribution are still non-overlapping. This distribution is actually pretty similar to the distribution on of what you have happens when you have all three of them together. However, if you look at this distribution, that of fortis, then that distribution has actually become wider. And interestingly, it has not become wider in both directions, so it is still non-overlapping on the lower side. But if you look at the right hand side, you see that this has essentially gone into the zone of what on this island would be the zone of this other big bird, the magninostris. Interestingly, when you find the same species on its own on another island called Daphne, then this thing ends up going somewhere in the middle. So you can see now it is happily overlapping quite a bit with Fulginosa. And similarly, this Fulginosa, when it is found alone on one of those islands, then you see that it shifts a lot towards the right hand side. So this phenomena by which the trait distributions differ more when species coexist than when they occur in two different areas, this phenomena is what is known as character displacement. Okay, and this phenomena is supposed to be a result of competition, due to which species end up changing their morphologies in such a way such that, I mean, in this particular case we know that these distributions have a direct mapping with what kind of resources they are able to tackle. So it is thought that here, in the case of this one, this case where all three of them are occurring together, this shifting has actually reduced the competition amongst these three by shifting their resource bases slightly. Okay. So this is one way by which the species end up separating their niche, something that is very visible at the level of their morphology. Any queries? Hello.
Yes, sir. We can hear you.
Okay. Yeah. No,
So,
because
question.
bolo.
Sir, do these effects tend to be kind of pronounced in islands in particular because of the lower, like, because of the higher specialization of resources as such?
Um,
Like, dispersal is unlikely, so
possible. Uh, Quite a few of the examples are from islands, but there are lots of examples from non-island areas also. Okay, so for example, there have been examples from fishes and all, which, so far as I remember, were not found on island populations. But yes, see, the problem is that these things are going to happen when you have relatively few species interacting, right? Which is a case over here. But suppose there are 10 species interacting, and out of which two of them are not there, the remaining 8 are still there, right? So shifting this distribution when there are too many species is going to be a much more challenging thing as compared to when you have just one or two species. It becomes much easier to actually practically do it, and that is something that is more likely to happen in an island situation than in a mainland situation. Okay.
Sir,
Bolo?
do small beaks offer any particular advantage because the G fortress, when left
Hmm.
alone, it shifted towards the left instead of shifting towards the right?
No, so the idea is that, see, there is obviously going to be some kind of a lower threshold, okay, physiological minimum, and typically there is a physiological maximum. So the idea is that over here, these guys are being forced to, look at the, or use the smallest seeds available. However, when you leave them alone, then on their own they are a bit better off eating somewhat like more medium sized seeds. So the fact that they are not going towards the left anymore can also be because of the physiological minimum. That's what I mean. Okay. Does this answer your question?
Okay, sir, thank you.
Okay. Now, whatever we saw till now was primarily in the context of niche defined in terms of resource usage, and
Sir,
so on. Ha, bolo?
sir, I had a question.
Hmm.
Maybe a clarification. So,
Hmm.
in the islands of Floriana and San Cristobal, we
Hmm.
see that the beaks from the fortis are actually going quite a bit right towards in the region of Magniostris.
Yes.
But for Daphne, we are saying it's moving towards
Uh,
the smaller parts. Why isn't it getting much wider, like covering a longer region of
so yeah,
beach?
why is it not doing something like this? Yeah, that
Yes,
is,
yes.
yeah, that is a good question, and give a definitive answer. One possibility might be that by and large these islands are separated from each other. Okay, so maybe there is a genetic variation problem, because of which they are unable to create the variants which will end up taking this part of the space. Okay, that's one possibility. I don't know if Grant et al. Actually answered this question. Okay, I never found a good answer to the question that you are asking for.
So one possibility could be that the seeds are different, right? The
No, see
seeds
the
are
problem.
be different
If the
in sizes, like the distribution of
uh,
seed size.
no. See, the issue is that if you consider that the seeds themselves are different, then this entire thing will not work, because you can then explain all the distributions by the corresponding availability of seeds.
Yeah, so it would only work if you
Uh.
actually looked at what those distribution of seeds are
Ha,
and
ha,
then
ha, ha.
compared them and see how they are.
Yeah, no, which they did. That is a huge part of Grant's work. Okay,
Right.
that they explicitly, I mean, you guys saw that video. I don't know if you remember or not, but they actually took out, they took out all those seeds. They measured them. They, came up with average quality indices for the seeds. So measuring the resource was a huge part of what these guys ended up doing.
Yeah, so if you took that into account, that might have something to do with how the G40 species has behaved, right?
If that ends up doing that, then it won't be an example of character displacement, right?
True. Correct. Okay.
That's what I'm trying to say. Okay.
So, what are the timescales for the character, the niche separation here?
That's the beauty of it. It depends on what is the strength of the competition. So people have shown that sometimes this can actually happen very, very fast. This can happen within 3-4 generations. So for example, I think in some lizards or birds or something, they ended up showing, sorry, not lizards or birds, in some mammals, they ended up showing the differentiation on a time scale of about 10 years. Okay, which for mammals is very fast. So the essential point is that this can happen reasonably quickly. Whether the real players in the game, the real players in the game are A, what is the strength of selection, which is modulated by what is the strength of the competition, and the second thing is how much of variation is there in the population. Also a bit about how much plastic that particular trait is. Bolo.
So, sir, there has to be some generational gap, right?
Yeah, of course.
Okay. That was
Otherwise, it's not evolution, right?
Yeah, correct.
Sir, is there any reason why there is no overlap between the ranges of each species? I mean, why are all the graphs, all the Gaussians so separated? Is there any reason for that?
So that's what character displacement is all about, right? So when they are together, they end up, separating their distributions, and thereby most probably also separating the resources on which they are feeding. I mean, that is for this particular case, resources that they are using in a general case. That's the definition.
I get the fact that the characters are getting displaced in either direction for optimal resource partitioning, but there must still be some overlap between the tail of one Gaussian and the beginning of the other Gaussian, right?
See, that is a theoretical thing that you are talking about, minus infinity to plus infinity. But when you are looking at a sample of say a few hundred birds, then you won't be able to get those very low values. No, I mean, those tails will not exist. Number one, and second point is, remember, we are talking about 3 different species over here. So in all these cases, you also have physiological minimums and physiological maximums.
Right.
So these are anyway truncated distributions. These are not the theoretical minus infinity to plus infinity that you are thinking. Okay.
Sir,
yes.
Bolo.
So can it be the case that initially there was some overlap and the overlapping regions just killed themselves each other off due to competition? That's why they are so distinctly separated.
Can you just repeat that? I didn't get it.
So what I'm saying is, suppose there was some overlap even after character displacement, but in the overlap regions, because of the high competition, maybe the birds killed each other off.
No. This one, the top one that we are talking about, This is a small island. It is not like it's a continental thing where these are spatially separated. Here they are not spatially separated.
Yes, sir, I get that. But
Then
so suppose for one beak size, there are two species.
correct.
Even if they are less in number, there will still be some competition, right? So maybe, because of the competition, both of the species of that particular beak size were wiped out. That's why there's so much of a gap between the graphs.
Okay, I don't know how to refute that. That's definitely not the point. That that's definitely not how people think about this. See, the point is that all these competitions, etc., these are not really happening at an individual level. Okay, these are happening more at the population level. So for what you are saying to be correct, then what you are saying is there will be a few of let's say these guys with very large beaks, and the few of these guys of very small beaks, such that they fall in this region, and then these guys are competing directly against each other, right? That's pretty much what you are saying.
Yes, sir.
That is a rather tough to think, right? Because remember, these guys, they are, I mean, there is no matching per se. The competition is simply happening because they are foraging for food and getting the food and so on. There is no chemical competition or some such stuff over here. So it's hard to say that until and unless they end up fighting with each other, how they only these guys will end up killing each other and everybody else will be all right.
Okay, that makes sense.
Yeah. ठीक है?
Also, sir, is there any reason why the last graph is not a Gaussian?
There can be several things. Remember, these are no. Wait a second. Remember, these are all real data. Okay, and that also these are data from island populations, which are in general pretty small. Right. So maybe it's just a sampling thing. Maybe if you do it 3-4 more times, you will end up getting something more like this. So essentially, I think what you are trying to say is, do I see a bimodality over here? And I don't think, I don't think there is a bimodality, not in this species. Bimodality of big size is there in other species, but we'll come to those species when we are dealing with selection. Okay.
Sir, in general, is there any reason to expect any population distribution to be a Gaussian? Like, why should it be a Gaussian? There are hundreds of distributions.
There are hundreds of distributions, yes, but this is again an observation that several traits, particularly continuous traits, if you have a large enough sample size, then it typically follows the Gaussian distribution. And that comes from the fact that you have a bunch of things, all of which end up having some additive effect on that. So there is a mathematical justification for why Gaussian is so common. And what are the cases under which Gaussian fails, that is also well known. Yeah, that's CLT basically, correct.
Okay.
Sir, in this three graphs, there are no birds, the magnetostris, whatever that is.
Magnetostris. Magni means large, ostris means beak. Literally means large beak.
So is it because like they were not initially present, or is it because there was competition and then they became extinct?
This is most probably because they were not initially present. Okay, because as far as I know, I don't remember whether the grants ended up showing any local extinctions or not. Okay, so basically, as far as I understand this particular piece of work, the whole hypothesis is because this is how they have evolved in presence of each other. It's not that one of them have been wiped out. Okay? At least not while the grants were there. Okay, so now we go to the next kind of niche separation, which is very interesting. So I'll again explain the experiment first, and then I'll give you a definition of what is it that we're talking about. So, so this was work done on 2 different species of beetles, flower beetles. So these are those small red things that you see in your atta at home when the atta becomes a bit old. So the 2 species that Thomas Spark ended up studying. So this is another name which is almost at par with Gause and the Raymond Pearl and all those big fellows in early days of laboratory ecology. So Thomas Spark, he took this Tribolium confusum and Tribolium castaneum and then figured out that there are 2 major conditions, that environmental variables that are important for their growth. So one of them was temperature. So he took 3 different temperatures, 24 degrees Celsius, 29 degrees Celsius and 34 degrees Celsius. And for each temperature condition, he took 2 different humidity conditions, 30% relative humidity and 70% relative humidity. So in total, he had 3 conditions here, 2 conditions here, 3 into 2, 6 total experimental conditions. And for each one of them, he actually started a large number of co-cultures, and for all of them, he ended up also measuring the K values, okay, from monocultures. And so since there are a very large number of co-cultures, he ended up asking in what fraction is the competition owned by Confusum, and in what fraction of the cases is the competition owned by Castaneum. Okay, so let's first look at the 2 extremes. So when you have a cool dry condition, 24 degrees Celsius, 30 degree relative humidity, Confusum wins every single time. Okay, that's why you have 100% over here. On the other hand, if you have warm and moist condition, then Castaneum wins every single time, no issues. Okay. However, when you have intermediate conditions, cool, moist, moderate, dry, moderate, moist, and so on, then look at how the data goes. Then nobody wins all the time. Of course, there is some favored thing over here. So if you take the moderate temperature, if you make it dry, then Confusum will win most of the time. If you make it moist, then Castaneum will win most of the time. Okay. Similarly, over here, if it is warm and dry, it's 90-10. But the moment you make it warm and moist, it becomes 0-100. Okay. So essentially, the 2 points that are being made over here are: 1, if you change the physical condition, the environment basically, then that can end up determining which way the competition outcome is going to come. Okay, so which species wins will be a factor of that. And secondly, that cool, neat result that Gause was getting, that one species will always win over under all conditions, that actually is not necessarily true if you drill into it. Okay, so that's the second thing. And if you look at these values, if you look at the K values, remember the idea was that in general, whichever species has a higher K is going to win. And I mean, that's obviously assuming that their alphas are pretty close to each other. But if you look at it, that thing doesn't hold all the time. So okay, which was the case where it was not holding? Yeah, here. So if you look at this one, at this particular condition, although Confusum has a lower K, it actually ends up winning the higher proportion of the competitions, suggesting that higher equilibrium size does not necessarily guarantee that a species is going to win the competition. Okay. Now, if you guys remember, yesterday I said that this particular observation is very, very interesting, because this itself gives you a way in which you can have species coexisting. So remember, when species are in nature, then obviously there is a spatial angle to it. Okay, they are distributed over space, and in many cases we know that the environment can actually vary over reasonably small spatial scales. So if that happens, then whether you are finding coexistence or not will end up becoming a question of what spatial scale you have ended up taking. If you have ended up taking a slightly larger spatial scale where there are multiple conditions, then it will look as if these two species are coexisting. If you didn't know that the underlying conditions are actually different, then it will look as if these two species are coexisting in that area. However, if you drilled in a bit more, if you went finer, and you were actually able to identify that zone where the heterogeneity of condition did not lie, then you will see something closer to this 100-0 or a 0-100 case. Okay. So the essential point is, since the outcome of competition itself differs based on environment, therefore environmental heterogeneity can lead to a sort of partitioning. You live in that area, I live in this area, and this partitioning or this separation is what is called conditional niche separation. Okay. So that's pretty much it for this particular thing. These are the references. I'll give you guys these references. Any questions in the context of this one, this conditional niche separation?
So just a clarification, the equilibrium population sizes are for the species taken independently, yeah? Or in the presence of each other?
Yeah. Independently, no. See, otherwise here, in the last case, confusion is gone, right?
That's what I was wondering.
Yeah. No. These are some monocultures. I said
okay.
So. These are monocultures. Okay. So if there are no questions along this axis, then what I'm going to do is I'm going to first stop presenting. Yeah. Then I'm going to stop the recording. So once I stop the recording, then this class is dissolved. You guys can, people who want to leave can leave. People who wanted to meet me during the office hours can meet me. We still have about 20-30 minutes, and if there are questions that still don't get resolved during this remaining time, then I'll again come during the office hour. Okay? Or if everything gets resolved, then I won't. So okay, Raghunandan DR, are you there? Raghunandan? Hello, Raghunandan.